This lesson is about area of triangles. Because they're kind of tricky, I want to devote a mini lesson to that. And if you've watched the other little mini lesson or remember in class, area is the total number of square units needed to cover a two-dimensional surface. And again, a two-dimensional surface, what we mean by that is it has two dimensions, length and width, a base and a height, something measurable in linear measure, and then you would multiply those. So I'm going to first start out with right triangles. They're kind of easy. I mentioned this in my other mini lesson. And what you need to be able to do is you need to be able to envision a rectangle that these right triangles are inside of and find the area of that rectangle. So let's see, 1, 2, 3, 4. So it has a base or a length of 4. And it has a height of 3. So when I multiply those, I'm going to get 12 squares inside that rectangle that's highlighted. But I don't want the rectangle. I want the triangle. I want the area of the triangle inside, and it's half. So all you got to do is take half of that number. So 3 times 4 is 12. You're taking half of 12 because that's the area inside the triangle itself. So area, using A, is equal to 6 square units inside. Kind of like a sandwich. You ever have your sandwich cut into 2 triangles? Well, each one's half of the area of the bread of the sandwich. So think of it that way. Maybe that will help. This other triangle, try to envision it inside a rectangle. Okay, figure out how tall it is and how long the base is. So the base is 2. How tall is it? Looks like it's 4. 4. So I'm going to do 2 times 4 is equal to 8. And the area of that triangle's half. So the area of that triangle inside is 4 square units. You have 4 in here and 4 in here to equal 8. Okay, now we're going to do some triangles that are not right triangles. They're a little trickier. And again, you want to envision them inside a rectangle. And the best way to do that with this one on the left is probably something like this. And then what you have to understand is that if you could take this piece of the rectangle and this piece over here, you could put them together, you'd actually get another triangle that looks like that. So I'll erase all this. Probably looks confusing to you. So I do that one more time. So imagine there's a rectangle here. How long's the base? 1, 2, 3, 4, 5, 6. So the base is 6. Here's where it gets tricky. How tall is it? You can't count the height as one of the slopes. You have to measure the height straight up to the peak, directly straight up, going along a 90-degree angle. So it has a height of 3. The height is equal to 3. So if I do 3 times 6, I'm going to get 18. Well, 18 would be the entire rectangle. Well, we just want half of 18. So it's going to be 9. 3 times 6 is 18. And then we want half of 18. So half of 18, that's 9. So the area is equal to 9 square units. Hopefully you can see that. Try this other triangle here. Again, imagine it's inside a rectangle. Something like that. I'd make a habit of just maybe trying to draw it out or box it in. And how long's the base? Looks like it's 1, 2, 3, 4. Base is 4. How tall is it? 1. Straight up. Straight to the peak. How tall is it? 1, 2, 3, 4, 5. It's 5. So what's 5 times 4? It's 20, but that's for the rectangle. So you want to cut that in half. What's half of 20? It's 10. So the area is equal to 10. It would be square units. Ran out of paper there. Do one more tricky one. I think I have time for one more tricky one. This one's kind of an odd looking triangle. Again, imagine it inside a rectangle. I'd make a habit of boxing it in, and then I would make a habit of figuring out the height straight up to the peak. So the height is equal to 3. The base, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The base is equal to 10. So I'm going to do 3 times 10 is 30. Well, that would be for the whole rectangle. You want half of it. So the area of the triangle is equal to 15 square units, whatever they are. I hope this has been helpful to you. Keep practicing, especially with the triangles and the parallelograms, because they're kind of tricky. And always remember that to find the area of a triangle, it's base times height, and then you got to cut it in half or divide it by 2. And hopefully you can start to visualize that on the paper. Take my advice and box them in like that, especially if they're on graph paper or grid paper. I think they'll be very helpful to you, and envision it as half of a rectangle. If you have any questions, please ask.